If you don't know this tool, you are losing an opportunity to leverage the real power of the command line interface. And once you get this tool, this skill becomes your second nature when working in a terminal. This tool is an absolute classic. It's everywhere where there is a command line shell, on every Linux and BSD machine, on Windows with WSL. It's also pre-installed on every MacBook and Mac Mini around. Heck, it's even a part of the Android distribution since version 9. It's a go-to software for text data processing and reports generation for almost half a century. And today I will show you why its programming paradigm is so powerful that it's equally efficient for processing terabytes of DNA sequences and for sketching a quick and dirty one-liner for building a report from, say, kubectl output. Yes, this tool is called awk. I will tell you now how it came to be, why you might want to choose a specific implementation of awk, and of course, I will explain the main ideas behind awk programming language so that you will get awk once and for all. Which means you will be able to solve your daily problems when it comes to filtering, transforming, and reporting on text data. If you already use awk, maybe it's time for a refresher and an update on what modern awk is capable of. We will start slowly from simple one-liners and go up in complexity to a bank statements reporting tool, a reverse shell, and a Telegram bot. Once you finish watching this video, every awk snippet you will copy-paste from Stack Overflow or your favorite LLM's output is going to be crystal clear to you. If you are still not convinced that awk is worth your attention, listen to what Brian Kernighan, one of the original authors of awk, and also one of the fathers of UNIX, has to say in this regard.
But I think in terms of programming languages, you get the most bang for the buck by learning awk.
This is a fragment from an interview recorded in 2020, by the way. Now let's go back in time to the late 70s, because the genesis of awk will explain how this tool has in fact created the whole niche of programming tasks.
Bell Labs is changing the face of modern society. The transistor, the laser, the communications satellite, and cellular communications are but a few of its revolutionary innovations.
Bell Labs was a research facility founded by AT&T, the American telecommunication giant, think Google of the time, which had to ensure the company's longer-term strategic advantage. Apart from the already mentioned inventions, Bell Labs was also the birthplace of the UNIX operating system, the C programming language, and yes, awk. Awk, as well as UNIX and C, all of them were in fact byproducts of the real inventions created at Bell Labs. Awk, C, and UNIX came to light because researchers really wanted to scratch their itch. Professor Alfred Aho, who is probably best known as the author of the classical Dragon book on compilers, at that time, in addition to working at Bell Labs, was also teaching at the nearby Princeton University. And he needed that tool to keep track of budgets at Bell Labs and grades of his university students. Mind you, last time he was lacking a tool, Alfred Aho just wasn't satisfied with less than inventing a super efficient regular expression and string matching algorithm that many of us still use to this day. That is, last time Alfred Aho needed a tool, he created egrep, the extended version of grep. But for the new problems that Professor Aho wanted to solve, egrep was not enough, not even SED, another powerful UNIX utility also created just some years before at Bell Labs, could not fit the bill. So Alfred Aho joined forces with his colleague, sitting literally in the adjacent room. His name was Brian Kernighan, one of the early developers of UNIX, who is now known as probably one of the best technical writers. Alfred and Brian were busy creating a specification of the future language when Peter Weinberger, a mathematician from a Bell Labs group working on databases, expressed his interest in the project. By the way, Peter Weinberger is now contributing to the Go programming language at Google. So in a weekend's time, Peter wrote the first implementation of awk. It was a regular expression engine from egrep, ideas from add, line editor, about which I was talking in another video, and Snowball 4, a text manipulation programming language from the 60s. The tool that was built in 1977 by the three now legends of computer science was intended to be used just by them to solve their own current work problems. But very soon, other employees of Bell Lab discovered that there is a simple scripting language designed for data processing, a language that looks very much like familiar to many C, but which is 100 times more expressive and equally fast. People started using this new tool, and in a good UNIX tradition of giving commands short names, the authors came up with a three-letter name. You can now guess why. The awk language evolved. In 1987 it became a part of UNIX System 5 release 3.1 and therefore started spreading outside the research facilities of Bell Labs. It became clear that there is an enormous amount of data processing tasks people need to deal with on computers. And a pragmatic approach, coupled with simple syntax, convinced even people without any programming background to use awk, just like what happened with Python at some point of its history. And then since 1992, awk became a part of POSIX, a family of standards for operating systems interoperability, which is one of the reasons why awk is literally everywhere now. It could be on your phone, it's likely installed on your laptop, and it's there on your cloud VIA. The programming model of awk influenced the design of Perl, which in turn was an inspiration for Ruby. A throwaway tool, this is direct words of Alfred Aho, became an integral part of the UNIX toolbox for generations of professionals. And in a short while, you will see by yourself why when I'll explain the core ideas of the programming paradigm of awk. But before I go on with awk programming, I have to show you the differences between different awk implementations you may get access to. The original awk runtime, programmed by Weinberger, was later rewritten and extended by Brian Kernighan. There were syntax changes, for example, you could now define functions, so to avoid confusion with the original internal to Bell Labs version of awk, this release that made its way to UNIX distributions was called the new awk, or nawk. This was the version of awk described in the first book on awk programming. By the way, you can download it for free. It's absolutely still relevant to this day. And this is the reason why new awk is also called one-true-awk, or original awk. Another name for nawk is BWK, for Brian W. Kernighan, who still maintains it as free software. This is what I call a legend, good people. Not a long time ago, 80 years old Kernighan submitted a patch to the new awk that added Unicode support to it. If you work with BSD systems, open source derivatives of Solaris or macOS, which is based on BSD, you have nawk pre-installed. Of course, it has now features added after the original book came out. If you work with Debian or Ubuntu, the default implementation of awk on your system is called mawk. Mawk is the fastest and the most memory-efficient awk today. People report that it's especially effective with huge files. I could not find a reliable proof online on why mawk became the default awk in Debian. I think it was just a personal decision of the package maintainer at some point in history. On many other Linux distributions, most probably you would have gawk pre-installed. Gawk is the GNU implementation of awk. It's the most active and the most featureful awk that is, in my opinion, very close to general-purpose scripting languages like Perl, Ruby or Python. That is because gawk supports namespaces, importing libraries, binary extensions, two-way pipelines, network programming, multi-dimensional arrays, arbitrary precision arithmetic, native CSV support, and more. Gawk has a debugger, a profiler, and a code formatter. Important side note, Gawk and one-true-awk are the only implementations of awk that work properly with Unicode. And finally, if you are working with a disk space and memory constrained environment, you can use BusyBox awk. But keep in mind that you may need to double check what features it actually supports. From now on, everything I will demo should work with nawk, mawk, or gawk, but it will be the bigger programs where the GNU awk is absolutely required. I will specifically stress it out where relevant. In a short while, we'll dive into awk, the language. If you, like me, love to program in the evening hours and have trouble concentrating, and if you, like me, cannot sleep at night after drinking coffee, try Blended Ritual. It's a drink that tastes like cacao and which stimulates your focus not by silencing your body's tiredness monitoring system like coffee does, but by supporting your brain's cognitive functions. The drink is stuffed with mushrooms that have been used in traditional medicine for thousands of years. It's packed with vitamins and minerals, so even 1 cup a day is going to support your body in these stressful times we live in. I personally do not drink coffee after lunch anymore, but my productivity is not dropping like crazy because I stir a cup of Blended Ritual with milk and enjoy it, all without caffeine overstimulation. Good people, if you're interested, click on the referral link to order your package of Blended Ritual to support your evening creativity and my work on this channel. Thank you very much, and let's start with awk programming. First of all, let me start by showing you the different ways to run awk code. Awk is a data-driven language, and you can either pass a file name as the last argument or pipe data to awk from another command. And of course, where I say a file name, it can be a list of file names that you can supply whatever way your shell supports. For example, with a glob expression like this. Here my shell expands the glob with the star symbol to list all the header files in the user include directory. Awk gets all these files as input, except for the case where you load your awk program from a file with a -f option. You need to enclose your awk code in single quotes. Single quotes are telling the shell not to try to interpret what's between them. As you will see very soon, awk programs often have $signs and sometimes exclamation marks too. And these symbols have special meaning in shell. So whenever you see a weird error message when running your awk one-liner, first thing to check is the proper quoting. If you have to use a single quote in your awk code, just put /47 where you need it. To use awk effectively, keep in mind the following mental model of how awk operates. It's just the 2 core ideas behind awk. These ideas made awk so uniquely effective for data processing, and these ideas also explain the whys and hows of awk. So if later on your awk journey you will be thinking how this should work, recall these 2 ideas. Okay, so the first idea. Awk allows you to work with line-oriented text data like with a database. You remember, Weinberger was a member of a database team at Bell Labs. And the second idea. Awk works only by using a pattern action approach. Now I will unpack these ideas, and this is how I will teach you awk so that you get it once and for all. Let me start with line-oriented text data. Before UNIX, the platform on which and for which awk was developed, text data didn't get a deserved treatment. People at the time used Fortran for number crunching and COBOL for the things for which we would probably use spreadsheets these days. And if you wanted to work with text, you had a hard time really. There's a legend that UNIX itself was created because researchers at Bell Labs needed software to format their documentation. Whether true or not, only UNIX really made text data a first-class citizen in computing.
UNIX is a completely different operating system.
And one of the ideas that made UNIX so successful was the idea of small programs, each doing one thing well. These small programs had to interface with one another using plain text. By design, there were no constraints as to how text data should be represented. There was no JSON, no XML, protobuf, no data types, schemas, or anything like that. The only convention was to split text data by a new line character. And the innovation of awk was that it represented such line-delimited text input as a database, which means that an awk program interacts with text data in a sort of a declarative way. If you would have to do what awk does in a language like Python, you would have to open an input file, loop through it line by line, and place a bunch of conditional statements to act on lines which are interesting for you. In awk, what you have instead is an approach which is more like SQL. You describe what data you need to get from the database and what to do with that data. Again, maybe calculate something and print in a certain way. In SQL for relational databases, you deal with rows and columns. In awk, you have records and fields. It's important to remember these words because this is how things are called in awk documentation and in the book. A record is a line and a field is every part of the line separated by spaces and or tabs. You can absolutely redefine what records and fields are for your program, but for now, records are lines and fields are words. Now to the second core idea of awk. Awk operates only by using a pattern action approach. Every awk program is at least one or a series of rules which are separated by a new line or a semicolon. These rules are where pattern action comes into play. Action is always the code in curly braces. Pattern is what always comes before an action. Here in my example there are 3 different patterns and 4 actions. Yes, you can omit one element of a pattern action pair. You can have no pattern with a proper action, or you can have a proper pattern with no action. I will explain in a bit what happens if you have no pattern or no action. Patterns are what actually makes awk interaction with text input database-like. Behind every awk program there is an invisible loop that goes over text input record by record. As I said before, record is a new line delimited string by default, or simply put, a line of text. And for every such record, awk checks if there are matching patterns. And if so, for each matched pattern, a corresponding action is executed. Next record, check for all the matching patterns, execute their actions. And on it goes until there are no more records left in the input. Let's go over some examples. Suppose I want to find every record, remember record is a line by default, in my etc password file, where there is a :root or a :bin bash present. So you see in this little awk program I have 2 rules. Each rule has a pattern and an action defined. Rules should be separated either by a new line or a semicolon. I have a semicolon here. This is what you do when you write awk one-liners. Okay, so in awk there are several different types of patterns, and in this example I have the most common one. It's a string matching pattern. String matching pattern is always enclosed in slashes. What goes inside slashes is a regular expression. I've said that before, but pay attention. The awk code is placed between single quotes. This tells the shell that will now execute this command to restrain from interpreting the part in quotes and pass it as is to the awk binary. Exactly what we want. Notice that the password line for the root user is printed twice because it matches both patterns. Now I can make this one-liner simpler by just removing actions from my rules. And it will work the same because no action means go print the matching record. And by the way, here I actually re-implemented grep in awk. No surprise that grep was one of the inspirations for awk. Alright. I said that for string matching patterns, awk uses regular expressions, which means I can do something like this to match lines that start with HTTP. Or maybe this to match either records with OSPF or BGP in them. In awk, like in grep, you can say, find me everything that does not match the pattern. This filters out comments and records with TCP or UDP in them. Some of you maybe already started thinking, okay, fine, regular expressions, but what kind of regular expressions? What exactly is supported in awk? The best source of information here is the man page for the awk implementation installed on your system. Generally, to be on the safe and most portable side, just follow the book. So that was a string matching type of patterns. Another really useful type of patterns by the way, often overlooked even by many advanced awk programmers, is the range pattern. It looks like two string matching patterns separated by a comma. First pattern in a range pattern looks like an on switch. When it matches a record, it will pass that record to the action part of the rule, as usual, but also it will do the same for every following record until the second pattern matches. Second pattern will pass the record and turn the switch off. No more matching after it. A range pattern can help to filter whole sections of files. Okay, now you know that awk supports string matching and range patterns. This functionality you can still get with other command line tools like grep or sed. But the next type of patterns is where the true power of awk is. It's an expression pattern, but before I show you what's possible with expression patterns, let me make a step back and remind you that awk sees the world in records and fields. So far, we've been dealing only with records, but now it's time to really introduce fields. You can access fields in awk by using this special syntax, a $sign and then a number, or something that evaluates to a number. First field in a record has a number 1. Now, here's how you can use this knowledge to filter out cron tab instructions for jobs that have to be executed by root. Username comes as a field number 6 in etc cron tab. This is a nawk program with an expression pattern, which means match all the records from etc cron tab file where fields number 6 are exactly root. Of course, you can also use regex in expression patterns. This will print all the records from a locale aliases config file, where fields number 2 start from JA or KO. And now it's getting interesting. You can use Boolean logic. Essentially, anything that evaluates to true or false will do, even if it looks absurd. This awk program has an expression pattern that always evaluates to true for each record. With no action, it means simply printing each line from an input file. By the way, if we make this awk program even smaller, could you guess what will happen? Nothing is printed out. Now let's figure out what's going on here. Any valid awk program, and this program is valid because we don't see any error messages, so any valid program should have at least one rule, with at least a pattern or an action. There are no curly braces here, so we have no action. There are no slashes, so no string matching pattern is expected. No range pattern is used because there is no comma. It must be an expression pattern. We know that an expression pattern should be evaluated to true or false. And we saw in the previous example that number 1 evaluates to true. What do we have here? In fact, we have an empty string. Empty string in awk evaluates to false, which means that this pattern never matches and nothing is printed out from the input file. Just like in C, in awk, everything that is not a 0 or an empty string evaluates to true. Not like in C, awk counts everything from 1. Fields start with 1. And as I will show you in a short while, arrays are indexed from 1 as well. Okay, so string matching patterns are enclosed in slashes. Expression patterns are whatever comes without slashes. Now let's make a step back to range patterns again. I've shown you before that you can put two string matching patterns and separate them with a comma to define a matching range with an on and off switch. This is a very powerful declarative way to query input data. What's even more powerful is that you can use a range pattern with two expression patterns. But before I show you an example, I need to tell you what are built-in, or I prefer to call them, magic variables in awk. Magic variables, just like variables for fields, you remember those with $signs, are set by awk itself during runtime. Magic variables do not use $signs, but they are always uppercase. Some magic variables are implementation specific, but what I'll show you here in my examples will work in any awk. So, without further ceremonies, here's the head command line utility, re-implemented in awk. This is a range pattern with two expression patterns for the on and off switch. Both expressions check the magic variable nr. nr is the current record number, which means the current line number in most cases. If the line number is 1, the range starts. If the line is 10, the range is over. Remember, the range is inclusive for its matching start and finish records. One last type of patterns in awk is what I call out-of-order patterns. Explaining them, however, is not really possible without finally looking into what actions are in awk. Patterns are just observing your data, but actions, the code that comes within curly braces, is where you create something new out of input data. Just with patterns you already have a very mighty grep on steroids, but only actions level up the game, and the combination of patterns and actions make awk a serious data processing tool. I already said that awk is a rule-based language. A rule is a pattern and an action pair. If there is no action in a rule, like in most examples up to this point, it means the default action is implied. Default action is to print the record passed to the action from a pattern. Now, if you have no pattern like here, it will match every record. Let me repeat. Empty string in a pattern matches nothing, but no pattern matches everything. It's easy to distinguish these two cases. If there is no pattern, you absolutely need to have an action. Let's continue re-implementing command line tools with awk. Here is the NL, the little tool that numbers lines. In this tiny program there is a bunch of things to discuss. You know that $sign is for field variables. You know that fields count from 1. But $0 is special. It means the whole record, a superfield. Now, if you have an experience with any other programming language, be it Python or maybe JavaScript, whatever, you may notice that the way an output string is defined for print is quite unusual. There is no string concatenation operator in awk at all. If you need to join strings in awk, and you will absolutely need to do that at some point, you just write those strings one by one. You don't even have to put a space in between, so this still works. Here I joined the magic variable nr, a space, and a superfield variable which stands for a whole record. When awk was in its very early stages of development, there were disputes between its authors on this syntax decision, but in the end, concatenation of strings by just cobbling them together became a part of the language. One more thing which may look fine for people often writing shell scripts, and which may make many other developers feel uncomfortable, are the missing parentheses around print arguments. In fact, you can use them, but parentheses around function arguments are optional in awk. What else you can do in actions? Pretty much everything you would expect from a general purpose language. You can, as you just saw, call functions like print, you can do if-else branching, loops, and of course assign variables. The syntax in general looks like a mixture of C and shell code. Okay. Now that you know just enough about actions, let me go straight to the last type of patterns, out-of-order patterns. Out-of-order patterns are very easy to distinguish. They are just uppercase words. An out-of-order pattern must be followed by an action block. There is an out-of-order begin pattern here, which, easy to guess, matches when awk just begins processing its input. And in the corresponding action, I'm setting a magic variable fs to a colon. Fs is a field separator, which is by default set to white space. But in etc password file, fields are separated by colons. So I use the begin action to change the field separator before the actual input processing begins. And then, in an expression pattern that follows, there is another magic variable, an f, which stands for number of fields. $sign is only used to access fields, and yes, you already saw me using numbers with the $sign. $1 gets you the contents of the first field, $2, the contents of the second field, and so on. But you can also use variables that contain numbers. So here, $nf means get the value of the field by the number that is stored in the variable nf. Nf is a magic variable that always equals to the number of fields, or, in other words, the number of the last field, because awk counts from 1. To summarize, this little awk program prints usernames for users that have proper login shells that end with sh. Now, to print some home directories instead, which are stored in next to last fields, I can do a little math on field numbers. This is the updated program. Notice parentheses around field number math. Here's one more example with an out-of-order pattern. It's rather long, so I've split the code into several lines by using backslashes. Backslashes inform my shell that lines should overlap, and this makes my former one-liner much more readable. And the goal of this awk program is to report the number of lines in a log file by counting fields that have double i's or the two w's in parentheses. Out-of-order end pattern is used to print the report exactly when we need it, when the input processing is complete. Now, instead of using just two simple variables as counters, I decided to show you here what associative arrays look like in awk. In awk, there are two data types. A single value data type is what you saw before in most of my code examples. Field variables and magic variables are single value. Single value data types are called scalar in the book. All scalar values are stored internally as strings, but as long as the string looks like a number, you can do math with it. In awk, you just start using a variable where you need it, and it's automatically initialized to a value that is kind of existing in a quantum superposition. It's an empty string or a zero, depending on how you use it. This approach absolutely makes sense in a language that is designed to work with text data. The second data type in awk is an associative array. This is how Brian Kernighan explains what it is.
So an associative array, just for clarification, is an array whose subscripts are not necessarily numbers, but could be arbitrary, let's call it strings of text, something like that. And certainly associative arrays are a very, very useful thing. And if you're only going to have one data structure, that's the one to have, because you can build everything else with it if you want.
If we just quickly revisit my example with the log file, you could see that I'm using an associative array called MSG, and there are two keys I use, warn and info. Values behind those keys are automatically initialized to 0 the first time a corresponding action block executes an increment operator on them. Keys in associative arrays can be strings. Remember, strings in awk have to be enclosed in double quotes. And you can go as far as even using whole records for keys, like in this UNIX command line tool reimplementation. What happens here? There are no curly braces in this program, so we have no action, which means the default action is in play, the one that prints records matched by the corresponding pattern. And because there are no slashes and no commas, this rules out string matching and range patterns, so the type of the pattern here is an expression pattern. It's a piece of code that selects which lines will be printed. So how does it do its work? You see, there is an exclamation mark, which is a not operator. It means only those lines will be selected for which the code evaluates to false, because not false is true. Then we have something with an increment operator. Increment is a math operator, which means its result will be a number. And I already said before how numbers are turned into true or false values. If it's a 0, awk is false. If any other number, awk is true. So our whole expression with an increment should be a 0 for this pattern to match. 0 is false, but the exclamation mark reverts, so false becomes true. Now, how do we get a 0 or anything else to the tricky part of the little expression pattern? Because there are square brackets, this seen word is the name of the associative array. Keys for this associative array are whole records, whole lines, which is what $0 stands for here. In awk, there is no need to initialize variables, be it scalar variables or items in arrays. You just start using them. So if we try to access a key of an array, a key that doesn't yet exist, it is automatically created. And because scalar values are in quantum superposition, they are strings and numbers at the same time, in this program they are forced by an increment operator to be numbers. Default number is 0. And here, pay attention, increment operator has two versions. It can go before a thing it needs to increment or after it. If it goes before, it first increases the thing by 1 and then returns it. However, if increment operator goes after the thing, it returns that thing as it is and then behind the scenes increments it. Which means if this awk program sees the record, the line of text, for the first time, the key in array is created and the value is set to 0. This 0 is returned. It's reverted by the not operator to become true and the pattern matches. But then increment behind the scenes increases the value by 1, so the next time the same line is found in input, pattern will not match because any number that is not 0 turns into true. True is negated here, making the pattern not match. This is a very creative, although quite hard to understand at first, example of use of associative arrays in awk. And of course, associative arrays can look like normal arrays if you use numbers for keys. Imagine I need to get a PostgreSQL major version number from a pgctl output. This program uses a built-in split function to cut a field number 3 into parts, separating them by a dot. Results are stored in an array called version. Major version is the first part of a version number, and here we print the first item in array to get it. Once again, fields start with 1. Array indexes created by functions like split also start with 1. Up until this moment, my awk programs worked only with the main input stream, either an input file or, like in the example with pgctl, data coming from another shell command by a pipe. There was also only the main output stream in examples so far, the standard output going to the shell. But in awk, like in any general purpose language, you can work with many input and output streams. You can read from and write to any number of files. The syntax is the same as in shell programming, redirection and pipes. In this example, which is a very primitive server monitoring script, I will show you how you can write a log file from your awk program. It will print a message to the console when high CPU usage is detected, and in addition to that will write performance metrics to a log file. A flush is needed because awk buffers output, and if you interrupt this monitoring script with Ctrl+C, you can lose log entries. A flush makes sure data is written to cpu.log immediately. Now let's imagine we deploy this script to production. Writing to a file is not an option, we need to use journald. Here is how you can write to a process from awk. Again, if you ever wrote a shell script, there is nothing unexpected here. Just don't forget to use quotes around the command you are piping to. Reading from a file or an external command works with the same input redirection and a getLine function. GetLine has a lot of different ways to use it. I will show you later some of the most interesting ones. Okay, at this point you know enough awk to look into some serious stuff. My new bigger awk program is an example of a very typical way you would use awk. Most banks allow you to get statements in CSV format. Now imagine I want to process such CSV statements for the whole year and get a report which splits all of my bank transactions into buckets. Those was the amount of up to €10, from 10 to 100, from 100 to 500, and so on. And then I want to know which percentage, in terms of amount of money and in terms of number of transactions, each of these buckets is. And then I want this report split by month. I won't go over the whole script. You can check it on my GitHub. The link is in the description below. But I'll show you what the results look like. I supply here a whole bunch of real CSV files with my bank statements. As you can see, for example, there's typically only one transaction per month that is €1,000 or more, but this transaction is almost a half of the money spent each month. It took me about 15 minutes to write this script, but it can already give me some interesting insights on my financial data. But numbers can be boring, so my new example is a reverse shell. Reverse shell is what bad guys use to get better control over a compromised machine once an exploit is applied there. The idea is that a reverse shell runs on a hacked host and calls back to a control host which is managed by an attacker. This is done to get around firewalls and nets in the network where a hacked machine is.
Come on now, we're just going to press buttons and hack computers.
We are not going to break into other people's systems, of course, but this reverse shell code I found online is an actually good teaching material. To run it I need GNU-awk, because it's the only awk implementation that supports networking. Let me dissect what's going on here, line by line. There is only one rule here, with an out-of-order begin pattern. Inside, there are two variables, rhost and rport, which are not defined anywhere in the code. This is by design, as I'm going to pass values for them from the outside when I will run this awk script. Now, the first line in the begin block sets a variable which contains a rather weird string. In awk, everything is a string really, so even for network programming you are not dealing with sockets directly, but instead you use special string values that look like file names. I haven't seen such a simple and effective abstraction for network programming in any other language. But what fascinates me even more is how this abstraction fits into the awk language as a whole. To make network sockets useful, you need to have a two-way read and write access to them. This is where another innovation from GNU-awk comes into play. To work with the network connection instead of well-known shell redirection operators, I need to use a pipe ampersand operator. But first I need to start an endless loop. Then inside its body, I'm sending a command prompt, the greater sign, to the network connection, which is represented by the variable s that contains a file-like network address. Then on the next line, I'm reading from the network connection into variable c. I'm immediately checking whether I need to break out of the endless loop and effectively end the script's execution. I do this by checking if the return value of my getLine call is 0 or less. 0 would mean that the other side decided to close the connection, and -1 indicates that there was an input-output error, which means that the connection was broken for some reason. If the return value is not 0 or less, then the connection is in OK state and the reverse shell script can proceed. And there is another loop, the actual meat of the reverse shell. What it does is it first checks if whatever was received from the network connection, the value of variable c, is not empty. And then it takes whatever is in that c and executes it as a shell command, reading results in another get line. Each line of the command output is another iteration of this loop. What happens in the loop is an interesting feature of getLine. If you are not storing getLine result in a variable, this result appears as a normal awk record, which is split into fields as usual. So $0 here means the output of getLine from the executed command. And it's immediately sent over to the network connection, line by line, just as the script reads it from the shell command's output. And once there is no output, which makes getLine return 0 or -1, the loop is over, and we close input and output related to whatever is behind variable c. Then the outer, endless loop starts over by sending a command prompt, checking whatever comes from the other side, and running another shell command. Now, from theory to practice, this is how reverse shell works. First, let me start the listening part, which is supposed to be located on my control server. In my demo, it will be running on the same machine. And here comes the shell. Now, the control server has proper shell access to the machine where the reverse shell is running. Now let me close the session. As you can see, the shell exits. This is 0 received from the network connection's get line.
Very smooth little job.
In my last demo, I wanted to see by myself what it is like to write a bigger program, which is also not focused on data processing in awk. As usual, the code is on the Art of the Terminal's GitHub, the link below. And in this code, I introduce custom functions. Custom functions can be defined anywhere where you would place an awk rule. Custom functions in awk look and feel just like functions in any other scripting language. This program is a Telegram bot, which, when it receives an HTTP URL, goes fetches that web page, sends its text to OpenAI API to get a summary, and sends that summary back to Telegram. The bot also uses Redis for caching. Although I wrote a simple working Redis client in plain awk more than 10 years ago, just for fun, today there is a much better way to work with the popular key value store. GNU Awk supports dynamic extensions, which you can use in your code with an @load statement. There are not many extensions out there, and the best maintained collection is called gawk_xlib. The bad thing about extensions is that most likely you would need to compile them on your system. But the good thing is, I did it, and it was fairly easy. In my bot application, I've used dynamic extensions for Redis, JSON parsing, and the one with a slip function. Documentation for extensions is very straightforward, so there were no questions on how to use them. I've also tried 2 other features from GNU Awk that are a must-have for a bigger application: includes and namespaces. Includes allow you to split your code into files and load them where needed. In Python, you would use import statement for that. In Gawk, it's @include. Just like in Python, you can load files with code from well-known system directories or by using path relative to the current file. In awk, All functions are global, so namespaces give a chance to organize them better. One thing that was quite unexpected is that in a file where you declare your custom namespace to use some built-in functions, you need to prefix them with an awk namespace. The key point to use some built-in functions. Most of them work just fine. By the way, gawk doesn't like omitting parentheses when calling custom functions. It will warn about it when parsing your script.
It's a warning.
In awk, there are only two scopes, global and local. By default, all the identifiers are global. If you start using a variable in a function body, it still becomes global and therefore reachable outside of that function. But function parameters are local. And because in awk there is no syntax for declaring a local variable, the only way to limit a variable scope to a particular function is to put that variable name in function parameters. By convention, developers visually separate real function parameters from function parameters that are really local variables, like here or here. And the same code that would normally create a global variable if it's placed below a net namespace statement will create not a global variable, but a variable in that very namespace. All in all, programming in awk is fun. If I just keep in mind the two core ideas behind it, text input as a database and the pattern action approach, reading or writing awk code comes with no surprises. There are absolutely no quirky or ambiguous syntax constructions in awk. Awk is very regular, and it really doesn't matter whether you are writing a quick throwaway one-liner or a bigger program split into many files with many functions. Awk is also a very focused language. It doesn't have as many features as, for example, Perl or Python. There are only two data structures in awk. Every line of code in awk is either a part of a rule, pattern or action, or a custom function definition, no exceptions. Yes, there are no thousands of packages covering all possible needs and coding styles. You won't find any frameworks with thousands of GitHub stars, no conferences, no popular streamers talking about awk. And you know what? I think it's a good thing, because all that abundance of choice and all that endless hype cycles are killing creativity, really. The great cathedrals of the past were all built with simple masonry tools. And no, I'm not advocating building the next Django killer in awk. Exactly the opposite. Forget about Hacker News bragging posts. Forget about other people's opinions bombarding you on social networks. Awk, maybe not the sexy type language that is going to change everything next year, but it's around for almost half a century, and it's literally pre-installed everywhere, because there is so much text data processing tasks around us, and awk is damn good with it. You won't choke on huge inputs. Awk will start fast and will run as fast as possible, doing just what it was told to do without ceremonies. You don't have to set up a development environment to start writing awk. To read awk documentation, you don't have to leave your terminal. You can do much more with awk than you probably thought. For inspiration, there is a roguelike game, a Git reimplementation, a file manager, a testing framework for command line applications, even a terminal graphics library, all written in plain awk. Heck, nothing stops you from writing a Lisp interpreter or a compiler in this little odd language. Because good people, it is exactly the frugality and the focus on the task, not the syntax, what brings you into a flow state. And the new perspective you get from using a data stream-oriented language is what, in my opinion, boosts creativity and can eventually bring back the joy of programming. That joy that inspired the legends from Bell Labs to design and build awk language. I wish you to be in the flow and experience joy when solving tasks at hand, big and small. Thank you for watching.